So in this problem, we're supposed to minimize this function z equals x plus 2y. But then there's these constraints. So basically we need to graph this first of all and find out what that area is. And so it might look like something, when we're done, it might look something like a triangle. And then a triangle has 3 vertices. And we'll just take those numbers from the vertices, each one of these, and then plug it into this function and find out what will make the z the smallest. Okay, that's the general idea. Now to find out what this graph actually looks like. So start with the first equation. So 2x plus 3y, and then change it to an equals sign, so equals 30. And then we need 2 points. So it would be easiest if you plug in x equals 0, because this would be gone. And when you divide by 3, that means y equals 10. Okay, next up, if you substitute y as 0, that means this is gone. And divide both sides by 2, and it says x equals 15. So then I could graph that information. Notice down here, it says the x and y both need to be positive, so I don't need to make x and y axis like this. I can just use positive x values and positive y values, so I just need the first quadrant. So the first point says that if x equals 0, then y equals a 10. There's 1 point. The other one says if x equals a 15, then y equals 0. And then just make a nice straight line connecting those two. And since this had a bigger than or equals, that means I should be using a solid line. And also, because this one has greater than, that means that the shading has to be above the line. So greater than means that it's above the line. Okay, then move on to the next equation. So now use this second equation right here and basically repeat the process. So 3x plus 2y, and then change this to an equals 30. And again, just make a little table of values and say, what if x equals 0? So that means this would be gone. Divide both sides by 2, and y equals 15. And then go back to the equation, and this time use y as a 0, which means this is gone. And if you divide both sides by 3, x is a 10. And then graph those points. And I'm going to use blue for that. So go over to the graph, and the first one is when y equals a 15. So it looks like I just need to extend this graph up a little bit. Okay, so 15 would be up here. And for the second point, it says when y equals 10, so that would be right about here. And then connect those 2 blue points with a nice straight line. And again, the shading, because it's got a bigger than or equal, the shading means it has to be above that. So it has to be above the blue line, but it also has to be above the black line. So far, it's the places where it's both blue and black. And then just repeat the process one more time. So then with x plus y, and then less than or equal to a 15. So at first, just put x plus y equals a 15. And then that table is going to be easy to make, because if x equals 0, then that makes y equal to 15. And likewise, if y equals 0, then x equals 15. And I'm going to make that one red. So 15 is right there for the x value, and 15 is right there for the other point. And then connect those two with a nice straight line. All right, now with the shading for that one, it's got less than or equal, so that means it has to be under the red line. So that means that it's basically this region in here that is the region that we're talking about. And so it did turn out to be a triangle. The only thing is, I know where this vertex is, and I know where this vertex is, but I don't know where this vertex is. So that's where the blue one and the black one intersect. So that is the first two. Find out where the first two intersect. So basically, if I just go over to this side on the left, here's the first two equations, and then find out where these two on the left intersect. Well, let's see. I think that I'm trying to avoid fractions. Okay, I think I can do it without fractions. So what I'll do is I'll multiply this equation by a 3. So that way I get 6x plus 9y equals 90. So just distribute the 3 on that one. And then on the other equation, I'm going to multiply by negative 2, because that way it will make negative 6x and then minus 4y, and then distribute equals negative 60. So that way when I have these two equations left over, the two blue ones, and then I add them together, then the positive 6x and the negative 6x will cancel. As far as the y's, that's going to be 5y. And then 90 minus 60 is 30. So that means y equals 6. And then once I have y equals 6, I can go ahead and plug that 6 in for this y right here. So it would say 2x plus 18 equals 30. And then solve for x. So if you subtract 18 from both sides, that's going to say 2x equals a 12. 30 minus 18 would be 12. And then divide by 2, and x is equal to 6. Oh, that turned out nice. A 6 and a 6. So that's where the question mark was. So let me just erase the question mark. And so then this point is 6, comma 6. Okay, so for the vertices of the triangle, we have, well, there's 6, comma 6. There's the one at the top where that 15, the blue 15 is. So that is when x equals 0, y equals 15. And then the red one at the bottom, that's going to be 15, comma 0. Now that we've done the hard part, all we need to do is plug that information into this and see which one gives us the minimum z value. And I think I can do that work over here on the left. Okay, so when I test 6, comma 6 and plug that into the z equation, that would say z equals 6 plus 2 times 6. So z equals, that's going to be 6 plus 12 is 18. All right, there's one answer. Z could equal 18. So this one is done. Now go on to the 0, comma 15. So the 0, comma 15, if you plug that into the z formula, that means x is a 0 plus 2 times 15. And then that 2 times 15 is 30. So there's another answer. And now go to the last one. And so that is the point 15, comma 0, and plug that in to see what z equals. So that would be x is a 15 plus, the formula had 2 times y, so 2 times 0. And that means z equals 15. All right, we did it. And the final is, what is the minimum? So out of the 18, the 30, and the 15, that means that the 15 is the winner. That's the minimum. Wait, that looks more like a smirk. It's supposed to look like a smile. Okay, there we go.